Hi, welcome back again. This is Mrs. Thompson. Today we're going to continue solving more equations. In particular, we're still looking at quadratics, but today we're going to look at the quadratic formula, and then we're going to take a few higher ordered polynomials that sort of look like quadratics. So let's get started. Let's take this first one. So our quadratic formula, first of all, we need to remember what that is. It comes from the completing the square. If you remember, when we completed the square, we wanted to get something that looked like this. Okay? And then we would take the square root. So I'd have plus or minus. Okay? And then x would equal plus or minus the square root of b plus a. So I get something like this, okay? Now in our quadratics, we have ax squared minus bx, or plus c, okay? And so I actually have three numbers to be dealing with. Well, when I take all three numbers into account, remember, by completing the square, I would make this look like this, okay? So that constant ends up on the other side, which means the constant is what actually ends up underneath this square root, okay? But it's not just c, because in order to complete the square, we're going to add something here, right? So it's actually c plus or minus something. Okay, so what does it end up looking like? And we can take, and I may make another video on the whole proof of it, but for now, we're just going to state it and we're going to use it. And then you can watch the proof at your convenience if you like. So the way the quadratic formula looks is this. It ends up being negative b plus or minus that square root of b squared minus 4ac all over 2a. Okay, so for this particular equation up here, the a is 2, the b is negative 3, and the c is 5. So I'll have x equals negative b, the b is negative 3, plus or minus the square root of b squared minus 4 times a times c. And then I will divide all of that by twice a. So now let's simplify this. The minus a minus 3 becomes a positive. Negative 3 squared becomes 9. Multiplying all this together, negative 4 times 2 is negative 8, times negative 5 is a positive 40 over 4. So I end up with 3 plus or minus the square root of 49 over 4. Well, the square root of 49 is a 7. So I have 3 plus or minus 7 over 4. So if I do the addition, 3 plus 7 is 10. 3 minus 7 is negative 4. So the end result is 5/2 or negative 1. So that's my solution. So the solution set would look like this. Okay? Now the fact that these answers, one of them is a integer and the other one is rational, tells me that the original equation, the original quadratic, would have factored nicely. Okay, now let's try this again. So the b value is 4, so I'll have negative 4 plus or minus 4 squared is 16 minus 4 times a times c all over twice a. So reducing that, So I have 16 minus 4 times 3 is 12, times 2 is 24. So I end up with negative 4 plus or minus the square root of negative 8. Now here we have to remember that the square root of a negative 8 actually becomes an imaginary number. So that negative can pull out of the square root as an I. I can still reduce the square root. So the square root of 8 becomes 2 square root of 2. And then if I want to reduce this, I'm going to go ahead and take it and split it apart. So I'll have negative 4 over 6 plus or minus 2i square root of 2 over 6. This can then reduce. 4/6 reduces to a negative 2/3. 2/6 reduces to 1/3. And this is my answer. So x such that x equals negative 2/3 plus or minus I square root of 2 over 3. Okay, you can leave it as a single fraction instead of breaking it apart, but you do want to reduce it. So if you leave it as a single fraction, it is going to end up looking like this. Okay, so be real careful when you reduce. The 4 cannot just reduce with the 6. The 6 has to reduce with both pieces. Okay, so keep that in mind when you're trying to reduce. Now, so the first example I did has 2 real solutions, 2 unique real solutions. The second one, they're both imaginary or complex. So why is that and how do we know? Well, let's take a look here. The inside of the square root, that b squared minus 4ac, is called the discriminant. If the discriminant is negative, then I have 2 complex roots. If the discriminant equals 0, then the square root goes to 0, which means I'm adding and subtracting nothing, so I get one answer. Now, this one answer, actually what we will discover, is actually occurring twice. It has a multiplicity of 2, but it's the same one both times, so it's not unique. Okay, then if the discriminant is greater than 0, then I have 2 different real roots. Now those real roots could be rational, whole numbers, but they could be irrational, but they're still different from one another. They're distinct. Now why is that? Well, let's think about from back in algebra class. We learned that quadratics graph as parabolas. Okay, so if the parabola looks like this, it has one unique solution. If the parabola looks like this, then it has 2 real solutions because I can see them. But it could also graph like this, which means I have no real solutions, which means they are complex. Okay, so I can get 1 real, I can get 2 real, or I can get 2 complex. That's the different types of roots we can have. But all of them can be found by using this nice, handy formula called our quadratic formula. So you do want to memorize this and never forget it. Okay? It's important. You'll see it over and over again. Okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. You can even sing it if you like. I've heard it sung to Pop Goes the Weasel, but you need to memorize it one way or the other. All right, so let's look at a couple of other examples before we finish. Now, none of these are quadratics. They all have higher order exponents. But they're going to work similar to our quadratic. So let's start. I'm going to get this one equal to 0. And then I can factor out that common factor. And when I do so, I notice that it is a quadratic inside here. So I have x to the 4th times x minus 2 times x plus 2. The difference is I have this extra factor over here. But this still tells me that this one can equal 0, x minus 2 can equal 0, or x plus 2 can equal 0. So if I solve all three of those, it tells me that x could equal 0, 2, or negative 2. I just got more than 2 answers, okay, because it was a higher order, okay? In example 9, I've got 4 terms. So one of the methods for doing this is called factoring by grouping. So what I'm going to do is I'm going to take these first 2 terms and I'm going to factor out the common factor. So I can take an x squared out of both of them. Then I'm going to take the next 2 terms and I'm going to factor them. So they both have a negative 3, and that would leave me with x plus 2. Now, what I notice is that both of these terms, I've created 2 terms, and both of them have an x plus 2 in them. So if I divide out the x plus 2, if I take this out, and I take this out, and I divide it out, dividing it out would leave me with x squared minus 3. Now, if that's equal to 0, then I can set each part equal to 0. This one would tell me x would equal negative 2. This one tells me x squared is equal to 3, which means x is equal to, first of all, I'm going to take the square root of both sides, so I get the square root of 3. But since I took the square root on my own, I get 2 answers. So my solution set is x equals negative 2 or plus or minus the square root of 3. Again, I got more than 2 solutions because the degree of the equation was higher than 2. Okay? Now this last example is a little bit unique. It looks like it's an x to the 4th. So that's a 4th degree polynomial. But it goes from 4 to 2 to none. So what I find is that it can end up looking or being treated like a quadratic. So this first term is going to go to x squared and x squared. But the rest of the factoring is going to work the same. So the 24 can either be 2 times 12, or 3 times 8, or 6 times 4. Now, which of those combinations is going to get me to 5? Well, the 8 minus 3. So I'm going to put an 8 here and a 3 here. And if I check the outside and the inside, and I want it to be a negative 5x, so I'm going to make this one negative and this one positive, that will get me the negative 5x squared. So I'm going to make the 8 negative and the 3 positive. So that tells me x squared plus 3 is 0, or x squared minus 8 is 0. So I get x squared equals negative 3, which means x is plus or minus the square root of negative 3. So I end up with an I times the square root of 3. Or the second one here tells me x squared equals 8. So x is going to be plus or minus the square root of 8, which can reduce to 2 square root of 2. So I ended up with 4 answers. So my solution set is x equals plus or minus 2 square root of 2, or plus or minus I square root of 3. So I got 4 solutions because it was a 4th degree. So look for those grouping situations like in 9, or the quadratic-like equations like in number 10. Okay, and we'll get some practice on this in class. And if you need some extra practice and you're out there online, you can comment me down below and I might be able to post some extra practice for you. But hopefully this helps, and we will see you next time. Keep practicing.